If XLOOKUP is giving you -NA, it usually isn't broken. It's Excel telling you one simple thing: no match was found. The tricky part is that no match can happen for several very different reasons. In this video, you'll learn the most common causes and a fast way to diagnose each one. We'll start with the basics, like the lookup value not existing. Then we'll move into the sneaky stuff: extra spaces, numbers stored as text, and mismatched ranges. I'll also cover match modes, wildcard behavior, and what happens when your data isn't as clean as it looks. Along the way, you'll get a few practical patterns, like using IFNA, and quick checks that take seconds. The goal is simple. When you see -NA, you'll know exactly where to look first and what to fix next. Let's turn that error into a predictable checklist. Next step. First, let's anchor what XLOOKUP is actually doing. You give it a lookup value, a lookup array to search, and a return array to pull the answer from. If it scans the lookup array and can't find a match under the current match rules, you get #NA. That's it. So your job is to figure out why the match failed. A helpful mindset is to separate problems into two buckets. Bucket 1 is the value truly isn't there. Bucket 2 is it is there, but Excel can't recognize it as the same. Most #NA issues live in bucket 2. Also remember that XLOOKUP is exact match by default unless you change match mode. That default is great for accuracy, but it exposes tiny inconsistencies in real-world data. So before you rewrite formulas, confirm the 3 inputs are correct and confirm what kind of match you're asking for. Next step. Cause number 1 is the simplest. Your lookup value doesn't exist in the lookup array. This happens more than people admit, especially when the lookup value is typed manually, copied from an email, or pulled from another system. The fastest check is to search the lookup array for that exact value. If it's not there, the formula is correct to return -NA. Next, confirm you're searching the right column or range. It's easy to point XLOOKUP at a similar-looking ID column that isn't the one you intended. Also, watch out for partial IDs, like looking up 1042 when the table stores 1042-AB. If you need partial matching, you'll handle it differently, often with wildcards or a different approach. But for a standard lookup, step 1 is still the same. Confirm the value exists exactly as stored. Next step. Now the most common it is there problem: extra spaces and invisible characters. A leading space, a trailing space, or a non-breaking space can make two strings look identical, but compare as different. This is especially common with data pasted from web pages or exported from systems. Your quick test is to compare lengths. If two values look the same but have different LEN results, you've found the issue. The fix is usually to clean the lookup value, the lookup array, or both. Trim removes extra regular spaces inside and around text. Clean removes some non-printing characters. For non-breaking spaces, you may need substitute to replace char 160 with a normal space, then trim. Once you standardize the text, XLOOKUP stops returning #NA for ghost differences. Next step. Next up, numbers stored as text and text stored as numbers. This is a classic reason XLOOKUP can't match, because 123 as text is not the same as 123 as a number. It often happens with IDs, zip codes, invoice numbers, and anything imported from CSV. A quick clue is alignment, because numbers often align differently than text, but don't rely on that alone. Better checks are is text, is number, or simply multiplying by 1 to see if it converts. To fix it, decide what the correct type should be. If it's truly an ID, keeping it as text can be fine, but then both sides must be text. You can convert the lookup value with text, or convert the lookup array with value. The goal is consistency. Same characters, same data type, same match behavior. Next step. Another big cause is mismatched ranges. Your lookup array and return array aren't aligned. XLOOKUP expects those arrays to be the same size and correspond row for row or column for column. If you accidentally shift one range down by a row, you might still get results sometimes, but you'll also get NAA for values that should match. This happens when people select ranges manually instead of using structured references or named ranges. It also happens after inserting rows or columns if the formula references didn't update the way you expected. The fix is to reselect both arrays carefully and confirm they start and end on the same rows. If you're using a table, referencing the table columns directly is safer because the ranges expand and stay aligned automatically. Next step, let's talk about match mode because it can create Nash NA even when values feel close. With match mode set to 0, XLOOKUP requires an exact match. With -1 or 1, it can return the next smaller or next larger match, but only if the lookup array is sorted appropriately. If it isn't sorted, approximate matching can return wrong answers or unexpected Nash NA. And with match mode set to 2, you're using wildcards, which changes how characters like asterisks and question marks behave. So if you're troubleshooting, check match mode explicitly. If you want exact matching, keep it at 0 and focus on cleaning data. If you truly want approximate matching, sort the lookup array and be clear about whether you want next smaller or next larger. Next step. Wildcards deserve their own quick checklist. If you use match mode 2, an asterisk means any number of characters, and a question mark means one character. That's powerful for partial matching, like finding any product code that starts with a prefix. But it also introduces a trap. What if your lookup value contains a real asterisk or question mark? Excel will treat it as a wildcard unless you escape it. Another trap is forgetting that wildcards are text logic. If you try to wildcard match numbers, you may need to convert them to text first. And finally, wildcards can match multiple rows. XLOOKUP returns the first match it finds, which may not be the one you intended. So if you're using wildcards to avoid a nav, make sure you also control ambiguity in the data. Next step. Now let's cover duplicates, because they can hide the real reason you're seeing #NA elsewhere. Duplicates don't directly cause #NA. XLOOKUP will still return the first match. But duplicates often mean your key column isn't a true key. Then you start fixing #NA by changing the lookup value, when the real issue is inconsistent identifiers. Another duplicate-related issue is mixed formatting, where one duplicate has a trailing space and the other doesn't. One matches, one doesn't, and the behavior looks random. A practical approach is to validate the lookup column, check for duplicates, check for blanks, and check for inconsistent types. If the column is supposed to be unique, enforce that rule. Your lookups become predictable, and #NA becomes a real signal instead of a constant annoyance. Next step. Blanks and error values inside the lookup array can also lead to confusing #NA results. If your lookup value is blank, XLOOKUP will try to find a blank in the lookup array. If there isn't one, you get #NA. That can look like a formula failure, when it's really an input problem. Similarly, if your lookup array contains errors, those errors can interfere with related calculations that feed your lookup value. The fix is to guard your inputs. A simple pattern is, if the lookup value is blank, return blank. And if #NA is acceptable when something isn't found, handle it explicitly. That way you separate missing input from no match found from real formula issue. It makes your spreadsheets easier to trust, especially when other people use them. Next step. At some point, you'll decide that #NA is not an error, it's an expected outcome. That's where IFNA and IFERROR come in. IFNA is the cleaner choice when you only want to catch not found. It won't hide other problems like a broken range or a wrong data type. IFERROR catches everything, which can mask real issues and make debugging harder later. A good pattern is to return a clear label like not found, or return a blank, depending on your use case. If the result feeds another formula, a blank might be safer. If a human needs to act on it, not found is clearer. The key is intent. Use error handling to make the output usable, not to cover up problems you should actually fix. Next step. Here's a fast troubleshooting flow you can reuse every time. Step 1. Confirm the lookup value is what you think it is. No blanks, no extra spaces, correct type. Step 2. Confirm the value exists in the lookup array and that you're searching the correct column. Step 3. Verify the lookup and return arrays line up perfectly and cover the full dataset. Step 4. Check match mode and search mode so you're not accidentally doing approximate matching or wildcard matching. Step 5. If it still fails, test for hidden characters, and test for text versus number mismatches. This sequence keeps you from jumping to complex fixes too early, and it builds confidence, because each step either proves something is correct or gives you a clear next action. Next step. Let's wrap it up. When you see NA in XLOOKUP, remember it's a message, not a mystery. Either the value isn't present or the data doesn't match as Excel compares it. Your biggest wins come from cleaning spaces and hidden characters, fixing text versus number mismatches, and making sure your ranges are aligned. Then you can choose the right match mode and only use wildcards when you truly need them. Finally, handle not found outputs intentionally with IFNA, so your sheet stays readable without hiding real problems. If you want, I can also do a follow-up on building a robust lookup template that prevents these issues from happening in the first place. For now, tell me this in the comments. Do you see NA more often from spaces or from text versus number mismatches? A or B? And if this helped, subscribe for more practical Excel problem solving. Subscribe to keep optimizing your workflow and get back more of your time.